Hello and welcome to Alchemist Camp. This is lesson 1. We'll start at the beginning. First thing you need to learn Elixir is Elixir. Go to elixir-lang.org and click on the Install tab, and you'll see options for installing Elixir on whatever operating system you're using. After that, bookmark this page. There's a lot of good stuff. There are guides, there are links to learning resources. Really importantly, we have the docs. This is the official documentation for Elixir, and in it you can find pretty much anything you want to know about the language. Like, let's say you want to know how the replace at function works in the list module. Well, you just click through, you have the definition of it, you have an explanation, you have examples, and pretty much anything in the standard library you've got all that information for. So the docs are super useful. I find myself looking at them all the time. Next thing you need is a text editor. My text editor of choice is Visual Studio Code. It's got a whole bunch of users, so as a result a whole bunch of people are extending it, making plugins for it. It's got an integrated terminal, it's got a whole bunch of debugging utilities, and it seems that Microsoft is super committed to making it better and better and better every month. It's also faster than some other similar editors like Atom. But it's up to you what editor you want to use. I will be explaining some of the shortcuts and features of this editor that I use. Alright, let's get coding. Today's challenge is to make a guessing game where the program will guess a number that you're thinking of, and you tell it bigger or smaller when it guesses wrong, and it'll zero in on it. So like maybe you're thinking of a number between 1 and 10, it guesses 5. Well, you're actually thinking 7, you say bigger, then it guesses 8, you say smaller, then it guesses 7, and that's the game. So first thing, let's make sure we've got everything installed properly. I'm going to hit Control backtick to open the integrated terminal. I'm on Windows, so by default this terminal is PowerShell. You can change that in the user settings. You can make the default terminal Bash or even the old school Windows shell. Doesn't really matter too much. What we're doing today is all Elixir, nothing related to the shell too much, so it's all cross-platform. We'll type in elixir-v, make sure we have Elixir, and see what version. So you can see I have Erlang version 18 and Elixir version 1.5.0. Remember, Elixir runs on the Erlang VM, so you need Erlang to do anything with Elixir. Alright, now the REPL, or the interactive language shell, is started with IEX. Unfortunately, this is already taken by PowerShell. IEX means something in PowerShell. So we've got to type IEX.bat in order to open Elixir's IEX. Now we can just start typing things and it will evaluate them. So 4 evaluates to 4, 4 minus 2 evaluates to 2, 2 times 2 times 56 is 224. So we've got basically a simple calculator. We can also see single quotes, double quoted things. These are a bit different in Elixir, and the way we can learn more is with the inspect utility. That's just the letter I and then the thing you want to inspect. So notice if I inspect a single quoted one, it says it's a list, and it's got raw representation. It's 49. That's actually the ASCII for the number 1, and we can see the protocols that are implemented by lists. In contrast, we do a double quoted I. Now it's a string or a binary, and you'll learn more about this in the future. We'll cover more in future lessons, but basically the important thing to know now is that they're different things, and there are different performance trade-offs with lists and with strings. So lists are pretty expensive to look at anything that's far from the head of the list, but it's pretty cheap to cut lists in half and append them to each other, things like that. Whereas with binaries or strings, it's not so expensive to look at things far from the head, but it's more expensive to be cutting and appending, because then you're doing copies of whatever is in a string. So just keep that in mind for the future. We're going to make a file now. So I'm going to go up here, and I've set up my own shortcut to make a new file. Oh no, I haven't. I guess that was built in. Just Control A. Oh, there we go. And file names are snake case in Elixir. So guessing underscore game.ex. There we go. And notice once I typed ex, it changed to this little purple droplet. That's because I've installed the Elixir plugin, and whenever I do anything with an Elixir file, I get syntax highlighting and all that. Whatever editor you're using, install an Elixir plugin. First thing we have to do is make a module. So def module, and this is camel case, guessing game, do, and end. All the contents of the module go between the do and the end. And we're going to want a function in the guessing game to find the number between two numbers. That way, if you say, I've got a number between 1 and 100, the first guess will be the middle of that, or 50. How do we find a number between two numbers? Well, you may remember from math class way back in the day, that's the average of two numbers, or the first number plus the second number divided by 2. So let's check that out in the REPL first. So let's say we want the number between 2 and 5. That would be 2 plus 5 divided by 2. Now that's 7 divided by 2. Some programming languages would say 7 divided by 2 is 3.5, and others would say it's 3, because 7's an integer and 2's an integer, and it just wants an integer answer, and you throw away the remainder. Elixir will convert it into a float. We can see that by inspecting. It is a float type. We don't want floats in our guessing game. I don't want to, if I say I'm thinking of a number between 1 and 10, it's not really in the spirit of the game to be thinking 3.5. So what we need to do is have a division that throws away the remainder and just answers with an integer. It turns out Elixir has one. It's called div. So div 7, 2 is just 3, because it threw away the remainder. And we can check that with 13, 6 as we expected, 12 would still be 6. Also notice that you don't need these parentheses. As long as it's not ambiguous, you don't need to use parentheses in the function call. Okay, so our function will be called mid to get the middle number between two numbers, A and B. And just like def module, def has got do at the beginning and end at the end. We're going to return div A plus B divided by 2. Save that. You can see the dot here turned into an X, so we know it was saved. We can load this module, since it is a module that will compile now. We can load it into the REPL and then mess around with it. This is super convenient. So we use C, which stands for compile, and then the name of the module, or I should say the name of the file, guessinggame.ex. There's no path to worry about since we're in the same directory. Okay, now we've got guessing game. Let's inspect it. Okay, now we've got a whole bunch of information. So let's try using our new function. Guessing game dot mid 1 and 10, or 1 and 50. 25, that seems about right. How about 120? 110 is 5. Okay, so we've got a working mid function. Now let's have it say something. Let's have it prompt the user. We'll call this guess between a low number and a high number. And the way that you write output to the user is with IO, stands for input output, that puts or put string. Are you thinking of the number 5? Just hard code 5 so we can test that it works. Now we need to recompile since we've changed it since we last saved it, or sorry, since we've changed it since we've last compiled it. Guessing game. High is unused, low is unused. That's okay for now. Dot guess. Are you thinking of the number 5? Okay, that looks good. Now what we want to do is, instead of always asking the number 5, we want it to be the number in the middle of the low and the high. The way we do that is we use pound and open brace, close brace, and this will let us put logic into the middle of the string. In this case, the logic we want is to call our mid function of A and B. So mid, low number, and high number. So this is going to call the function mid that we wrote on the low and the high number that we passed into guess. Let's give it a try. Recompile. Another way you can do that is reload, which is R and then the name of the module. Guessing game, and it reloads it. Okay. Guess between 1 and 10. Well, that's still 5. That's what it said last time. Let's try 1 and 100. Oh, it's still the number 5. Oh, look up here. This is still a circular dot. That means I didn't save. I'm going to click and then hit Control S to save. Let's try it again. Are you thinking of the number 50? Okay, that looks good. How about between 1 and 30? You're thinking of the number 15? Alright, so we've got our guess working now. Next thing we need is to recognize feedback. Like the user has to be able to say bigger or smaller. We're going to make a function to do bigger or smaller, and then after that we'll figure out how to plug it into the program. So let's see, bigger is when the user says guess a bigger number, which means the computer needs to pick a new number between what it just guessed, or actually it should be at least one more than what it just guessed, and the high number. So that seems pretty simple. It's just defining a new lower boundary. Def bigger, low, high, do, and so we need a new low. New low is going to be equal to the minimum of, and I'll show you the min function here in IEX. Min of 4 and 9 is 4, because that's the smaller of the two numbers. The min of 14 and 9 is 9. Then max does the opposite. The max of 4 and 9 is 9. The max of 14 and 9 is 14, because that's the bigger number. So the new low is going to be the minimum of high, because you can't possibly, if you're guessing between a number between 1 and 10, you can't possibly have the minimum be higher than 10. And the guess we just made, which is mid of low and high, plus 1, because we've got to have one bigger than our previous guess. Then we just do another guess using our new low and the same high as we had before. Okay, let's reload and see if that works. game and guessing game dot guess 1 and 50. Okay, you think of 25. Say we want it to be bigger. Bigger, 1 and 50. Are you thinking the number 38? That's about halfway between 25 and 50. So looks like bigger is working. Now we need to make same thing for smaller. I'm going to show you something you can do in Visual Studio Code. Hold Shift and Alt when you have multiple lines highlighted, and then press down, and we get a copy below. We use this copy to make smaller, so smaller is basically the same thing as bigger. We just reverse everything in the function. So guess a new high. Instead of min, it's max. Instead of high, it's low. And instead of needing to be one bigger, we need to be one smaller, since you did just tell the computer it's got to be smaller. Then we're going to guess the new high, use the new high in the guess, and I'm not going to change the low, because if you said between 1 and 50, 25, guess smaller, well, that means the bottom is still 1. That's not changed. Okay, save this. It is saved. Reload. Excellent. And guess 1 to 50, 25. Now we're going to guess smaller, so it should be something between 1 and, or the midpoint between 1 and 25. It's 12. Okay, good. All right. So the next step is let's actually get this hooked into our program logic. We need to get input from the user. So we want the user to be able to type in bigger instead of guessing game dot bigger and then the original range that we'd given it. The way you do that in Elixir is with something very similar to io.puts. Instead it's io.gets or io.getString. You give it some sort of prompt. We'll say type something is our prompt. And then notice it prints type something, and it's waiting for me to type something. Blah, type something, blah, \n. This \n is the carriage return. That's because I typed BLAH enter. It recorded the enter. This is a little bit annoying having the type something prompt right next to what you have to type. So let's add this \n to the end of type something. So now it's going to be type something and a carriage return or an enter. And we can type on the next line. Not bad. Okay, let's put that into our guess function. So instead of io.puts, we'll use io.gets. And it's going to return the input that the user types. So we'll just call this user input. Oops, user input equals io.gets. Are you thinking of the number mid, low, high? So whatever the user types will be returned in input. We'll return that. We'll screen io.puts user input. Okay. Reload. Something between 1 and 50. Are you thinking the number 25? No. No. Okay. Oh, we've still got this carriage return, and we don't have one after the prompt. Okay, we'll add that end there. So now it's gonna let us type on the next line, and we got to deal with this this carriage return in the answer, because we don't really care about that. We're just interested in what the user typed before the enter. There's something you can call, or you can use, called string.trim that will get rid of a trailing n. So thing that will get rid of the trailing carriage return. So this is thing with a carriage return after it. String.trim just returns thing. If there were no carriage return after it, it would still just be thing. You could have a whole bunch of spaces and other junk. It still gets rid of all that. Just gets rid of all the white space. So I'm going to put, see if I can type here, string.trim. user input. Okay, let's reload this and give it a shot. Good. Yes, I'm thinking of 25. Yes, yes, okay, looks good. So next thing we want to do is we want to check if the value that the user put in here was the word bigger. The way you do that is with the equality operator. That's a double equal. It's just like in a lot of programming languages. So 4 equals 3? No, 4 is not equal to 3, so it says false. How about 3 plus 1? Yes, 4 is equal to 3 plus 1. We can use it with strings. Like so. Notice that the carriage return will mess that up, which is why we got to trim it. So if the string.trim input is equal to bigger, then this equality operation will return true, and if the user didn't input bigger, it'll return false. Bigger, true. Smaller, false. Okay, so that works. Now, instead of just checking for one thing, let's use a case statement. Case statement lets you look at the value of something. In this case, it's going to be string.trim of the user input, so the trimmed user input. And if that thing they entered was bigger, then, which is what this pointy arrow means, then we will call the function bigger with the low and high values that we got in from the guess function. Let's save that, reload. Are you thinking the number 25? Bigger. Are you thinking the number 38? Bigger. Thinking the number 44. All right, this is looking pretty good. Smaller. Oh, got an error because our case clause, or we don't have a case clause to match smaller. Well, that's easily fixed. Just go to the next line and use the same then arrow here, and we'll call our smaller function. Okay, I'm thinking of the number 15, smaller than 25, bigger than 12, smaller than 18. Yes, that's right. Okay, how do we handle yes? I think the best way to handle yes is just to have the computer gloat. It's not going to be a good winner. It's one of those programs. Ha! I knew I could guess your number. So now I'm thinking of the number 37. Bigger. Oh, smaller than 38. Bigger. 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 Oh, not biggier. Oh, that crashed. It's annoying. Okay, I'm thinking of the number 38 now, just so we can get a quicker example. Bigger. Yes. Ha! I knew I could guess your number. Pretty good. Now, how do we deal with bad input, like biggier, or if somebody just didn't answer anything reasonable at all? Well, the way we do that is we need a wildcard match. So when we get into this case statement, it will first check, or it's a case macro actually, it'll first check to see if string.trim of user input is bigger. If it is, it'll do this. Then it checks to see if it's smaller. If that matches, it will execute smaller. If smaller doesn't match, then it goes to the next line, checks for yes. If that doesn't match, it goes to the next line, and so on. We can use this underscore to be a wildcard match, which means it matches anything. So anything that didn't match bigger, smaller, or yes, we'll call this function where we'll just tell them bad input. Bad input. And then we'll call guess call itself actually, so it just repeats the process until they've put in good input. Reload. You thinking the number 25? No. No. Bad input. Alright, it's making me answer bigger or smaller. Yes. Okay. It's looking better. Instead of just bad input, let's tell the user what input they should use. Let's have it say type bigger, smaller, or yes. This isn't going to work. The reason is because I have quotes inside my quoted string, and that just has the effect of ending the quoted string here, and then the compiler doesn't know what to do with bigger. There are a few ways around this. One way is what's called a here doc, where you use a triple quote to begin it, and then a new line, and then you use another triple quote on a new line to end it. So now this whole thing is quoted, and it takes a triple quote to end or begin the quotation. But this is still kind of messy. There's a nicer way, which is called a sigil. I'm going to hit Control Z to undo those last several editor changes. A sigil is something you can look up in the docs for Elixir, but use a tilde, and this sigil is a string sigil, so tilde S. And after that, you can use a different marker for the beginning and end of the string. So we can use parentheses here, so tilde S open parenthesis. You'll start a string that goes on and on and on until you get a closing parenthesis. Although you could also use braces. That'll end when you get a closing brace. There's several different options you can use with it, and you just pick one that you're not going to use inside your string, and then it's a lot cleaner and you can have your quotes inside the string. Or you could have just made the whole thing a single quoted character list, but I want to keep it as an actual string. Saved it and reload. Bigger, smaller. Okay, it looks pretty good. Yes, let's give it some bad input. Okay, this is looking like a game. Now, admittedly it's a simple game. I would say we've made sort of a game, but it's pretty good for day one. It's got a problem still. It's everything in here assumes that the user is reasonable and uses a low number than the high number. But if they do it the other way around, it's going to break some stuff. So if we say guessing game dot guess number between 50 and 1, bigger than 25. What? 1's not bigger than 25. So how do we handle this? The easiest way to handle this is we just check the input at the beginning and make sure it's reasonable. So we can define another function called guess that still takes two inputs, low and high, and we have a when clause. So this function body is only going to get executed when low is greater than high. And all we're going to do is we're going to call our normal guess function high, low. So we just swap them around. And you know what? In this case, instead of calling them low and high, we should probably just call them A and B. Oh, what I did here is I highlighted the word and I hit Control D. That selects the next one. Now I've got three cursors here. I just type B, replaces them all at once. That's a pretty nifty editor feature. It's the same as in a lot of editors. Okay, so here we've got two definitions for guess. First one is called a guard. It just guards for when A is greater than B, and it calls the other guess. Let's save this and give it a try. Between 50 and 1, bigger. Okay, now it's working as expected again. The other thing we can do is there's another syntax for a function in Elixir when you've got a very short function, and it puts everything on one line. So instead of a do and then a new line and your content and then another new line and an end, you can just use comma before the do, parentheses after the do, and put the body on one line. Is that right? Bigger. Yes. Okay. So here we have it. This is our guessing game. Let's do a recap of what we've covered. So we have set up Elixir, gotten a code editor, we've made modules, we've made a module, we've made functions, both standard functions and one line. We've seen a guard clause, we've done user input, user output, we've learned a little bit about strings and how to interpolate things in them, and how to quote troublesome strings with the S sigil. We've looked at control flow with case statements, and we've learned a little bit about how Elixir treats numbers, and we've seen how to do a modulus division with div instead of with a slash. And we've also seen how to load our code from a file we're working on into IEX, and so that way we can go back and forth and experiment quickly and figure out how things work, and then put those things into the file, and then load it all up into IEX and so on. So it's a pretty good start. In order to consolidate this though, you've got to do more than just watch me do something. What you should do is use the same stuff that we've learned today and make a program where you solve a different problem that's related. So here is my challenge for you. See if you can make a program that greets the user and asks what their name is, and then responds to them by name. And if the name they enter is your name, have it do something special. So here's an example for me. My name is Mark, so I would have it recognize that. It would say, "Hi there, what's your name?" The user types Jack. It'll say, "Hi Jack, nice to meet you." If it says, "Hi there, what's your name?" The user types Jill. It says, "Hi Jill, nice to meet you." But if when it says, "Hi there, what's your name?" the user types Mark, it responds, "Wow, Mark is my favorite name in the world. I was programmed by Mark." So to do this program, which is obviously a silly example, but hopefully it's silly enough, it's a little bit of fun. To do this, you're going to need some kind of control flow, like a case, and you're going to need functions. You're going to need to use string input and output. So it should be a pretty good review of everything we've done here. If you get stuck, or if you have questions or comments or concerns or just requests for material to be covered in future lessons, leave those comments in the YouTube video below. And be sure to subscribe to the YouTube channel so you can keep learning more Elixir as I put out more lessons. That's it for today. Till next time, happy coding.